Hello friends, welcome back to the bench. I'm glad you can join me because today we have a PDA6BU amplifier with a Bluetooth, an SD card, USB, you name it, it has it. Two microphone inputs, auxiliary, nice little remote, very nice device. Came in for no power. Let's see what we can do. Okay, so this is what we have. The issue with it is relatively simple, at least at this point, but we'll see how much other stuff is broken because of that. A 12 volts plus minus comes here. That's our main power rail. Smoothing capacitors that goes through two relays that turn it on. It does turn on. It goes through this resistor. So negative 12 volts is stabilized by this regulator, 7912. The positive 12 volts is stabilized by a Zener diode, these two resistors, and these three transistors, and that goes to this connector, and it's nicely labeled. All the voltages, signals, and everything. Actually, everything is labeled over here, so that's very repair friendly. But one of these transistors is shorted. I tried using an ESR meter because I heard, or I've seen people do it, but actually I haven't actually seen people do it. I've seen people explain how to do it, but I have never seen a demonstration. And I couldn't actually find which one is shorted using the multimeter, using the ESR meter, because the distances are pretty close. Actually, according to my ESR meter, this one was supposed to be shorted, but obviously I used the old technique of connecting voltage, about 1.5, 1.8 volts, and just putting a drop of alcohol on each one of these, and whichever one evaporates first is the one that is shorted, because it's very unlikely that all three are shorted. So that's kind of a surprising method of stabilizing voltage, but I guess for some reason the plus 12 requires more current, because if you use 7812 regulator, you are limited to, I think, 2 amps. This transistor though, where do I have it? Yeah, this transistor is capable of breakdown voltage is 40 volts, and current gain, where's the max? Oh, collector current is actually only half an amp. Only half an amp. 3 of them, so amp and a half. So 7812 would have done the same job over here without the Zener diode and stuff. It's weird. Anyways, that is our problem. And now, since this got shorted, the full whatever voltage is here, and it's roughly 12 volts. Well, actually, it is 12 volts AC. So after bridge rectifier and capacitors, that's going to be closer to 18, 20. So I figured probably since that high voltage went to the logic board, and our logic board is here. Right here. You probably can't see much. I'll do my best. So it goes through here, and there's two op amps, and the third one is over here that is responsible for microphone, I think, or I don't know. And this little chip over here is I'll tell you exactly, yes, PT2399. That is echo processor IC, so it's only responsible basically for this knob, yeah, for regulating echo. So even if it doesn't work, I don't really need it. Anyways, I checked all the op amps, none of them are shorted, and that 12 volts, when I check over here against the ground, against negative 12 volts, no shorts. So I don't know what caused this much, well, other than shorted transistors, I don't know what caused so much current to go through this 100 ohm resistor. And only on plus 12 volts, not negative 12. Negative 12 was fine. So on that Zener diode, we now have like 50 ohms, because it's completely shorted. Collector emitter is pretty much a wire, and the base collector is about 50 ohms, something like that. And that's where we have the Zener diode to stabilize 12 volts. So hopefully I already ordered those little transistors, and now actually thinking about it, I probably should have just bought 7812 regulator and just put it here. But there's got to be a reason why they used 3 parallel transistors and the Zener diode and the resistor to stabilize 12 volts instead of using what they used for negative 12 volts. I don't know. There's got to be a reason, right? So if there are no shorts on this after replacing those transistors, we should have working amplifier, and that is the hope. Alrighty, so I replaced the transistor, actually not replaced, I removed 2 shorted transistors. One of them was not shorted. And just to test whether I'm gonna have 12 volts right now, this is just the voltage supply for the amplifiers, for the op amps. So there's not a lot of current going through this circuit. But I'm still not getting 12 volts because this Zener diode turned into a 50 ohm resistor. And why did that happen? And actually, by analyzing this, I realized that I ordered the wrong transistors. For some reason, I just read the number on it, and Google told me that it's a PNP, half an amp, and that's what I ordered. And then I realized that this circuit is not going to work with PNP. Come on, camera, focus. There you go. So this is very simple voltage regulator, completely linear. This is no different from the voltage divider, but this one actually has two capacitors on the base and the emitter of the transistor to stabilize the voltage. So obviously it's much better than the actual voltage divider. But this is all that excess energy will dissipate on these transistors, and we have we have 3 of them. That's why we have 3 of them, I assume. Each one can push 1.5 amps, so we have 4.5 amps. That's why this is not 7812, because this one can push only 2 amps. So for some reason it's good for negative voltage, but for positive voltage they're using this. But anyways, if the voltage, so the Zener diode here will just try to make the voltage 12 volts over here. So this is our controlling divider, 3.3K, and a Zener diode. So it should be 12 volts over here, which means around 12 volts on the output, which means all that, because we get 32 volt input through the 100 ohm resistor. This is the one that actually boiled and let out magic smoke, but I don't think it's damaged, so I'm gonna leave him for now. It just got a little bit roasted because of short over here, collector emitter short. So all that power, because the Zener diode tried to drop the voltage down to 12, so all that current had to go through the diode. And after 1 watt it just went short, and actually it's not short, it's around 50 ohm. So I'm effectively getting like I think around less than 0.1 volt over here, which means I'm getting less than 0.1 volt over here, and that's why it doesn't work. So now I just need to order a Zener diode as well, and this time correct transistors. Good thing I didn't connect it and actually build it with those transistors that I ordered, and good thing that Zener diode was also broken, because otherwise I would just put the other transistors in and it doing it. So PNP would be like this, so it's basically not going to turn on, so there's going to be 0 volts here if I did connect. So it wouldn't break anything, it just still wouldn't work, and time wasted. But I still ordered those transistors because it was too late when I realized I already placed the order, and they don't let you avoid the order or add anything to the order. So I lost like $7.50 on shipping, I guess. Alright, now let's just wait for the Zener diode, replace it, and see what else is wrong with the device. Alrighty, transistors are replaced, Zener diode is replaced, everything is put more or less back together. My oscilloscope is switched to the battery power. It's connected to the output via or across 100 ohm resistor, which is our simulated output, very low power. And I'm gonna use the phone. This is beauty of the devices with Bluetooth input. So this is also battery powered and it's not connected to it, so it's not interfering. And I'm gonna push 528 Hertz wave. So let's turn the guy on like so. Yeah, I'll fix that later. Now disk, first we want Bluetooth initializing, unconnected. It should connect, because I already paired it, so it should connect automatically. Yeah, it's connected, beautiful. Now let's push our 500 Hertz and see what happens. There we go. It's distorting a little bit, but yeah, it's not perfect, but it's good enough. We have 1 volt RMS on the output. The resistor, no, it's not even getting warm. Let's see more. Yeah, at this zoom level it looks beautiful. Okay, this is maximum volume, and I don't see any clipping, so that is nice. But this is 100 ohms. Anyways, this is not what I wanted to show you guys. What I wanted to show you is this. So I replaced, I'm actually gonna turn it off now. Let's turn off the generator and see some commercial. Let's turn it off. So negative 12 volts is stabilized by, let's see if we can do this. There we go. Okay, so this is what is stabilizing negative 12 volts. Positive 12 volts, as I showed you on the schematic, is these transistors, this resistor. Let me get something that I can point with. Yeah, so this resistor, these 3 transistors, and this Zener diode. That's what stabilizes positive 12 volts. And both these go to our op amps. And there's one of them over there. I checked, they don't get hot. So now, what is the problem? The problem is that this, as you can see, it works, right? I can play music on it, everything works. So it is repaired. I replaced these transistors with exact same ones. The Zener diode, I put a little bit beefier one. I think half a watt more than it was, 1.5 watts, and it's supposed to be 1 watt. So it's gonna withstand a little bit more current before it breaks. But this has a radiator, the heatsink, right? Because it dissipates a lot of heat, and these don't. That's why there's 3 of them. Okay, but they get very hot. You can't even touch them, they get so hot. So they're operating at around maybe 70 degrees Celsius, maybe 65, 70 degrees. It's basically, you can't touch it. It's so hot. So this is not designed to work under such temperature. I thought that maybe there's still like something that is shorted on this side, but then it would also be getting warm, and I don't feel anything getting warm on this side. So I think it's just a huge design flaw, doing it this way, because I'm sure this is gonna break exactly the same way. I'm actually gonna look for other of these broken devices, this exact ones, and if the price is right, I'll buy them and check if this is the same issue. But looks like, and on this device, this is just gonna fail. Not only these heat up, but they're next to a big heatsink over here. And if I remember correctly, these two broke, the ones that are closest to the heatsink. So it doesn't seem like this device should be powered like this. I think this needs to be replaced with something else, and I have a candidate here, which is medium power NPN transistor. Characteristics are, well, this is general purpose transistor, so pretty much almost anything can replace it. So I'll try replacing it with these and see how long that's gonna last. But first, I want to wait for it to break again. So I want to test it for like maybe a week, maybe 2 weeks, hopefully maybe 2 days, and it's already gonna break. And then I'm gonna try to fix it, and it's gonna be upgraded device from that point on. If you guys have any suggestions what to use instead of this, I was considering just 7812. Remove the diode, remove this resistor and these 3 transistors, and just put 7812 on it with the heatsink, and I think that would probably solve the problem. But I'll probably try these transistors as well, and we'll see what's gonna work better. But if you have any suggestions what to use, definitely drop them in the comment. And I thank you very much for watching, and I shall see you in the next one.